So we're preparing an apparatus to be used on another planet, planet Caasi, and given that 25% of the volume of the apparatus if placed on seawater, 25% of the volume is submerged. What is the volume submerged on this new planet? So we have the density of seawater, which is going to be 1030, or rather 1030 kilograms per meter cubed. And then we have the volume of this apparatus is going to be 0.25 V on Earth. And we have the density of glycerine, which is going to be 1,260 kilograms per meter cubed. And then we have we're trying to find the volume 2 equals on Caasi. So first we need to recognize that on Earth, the buoyant force, in order for this to float, the buoyant force must equal the force of gravity of this apparatus. So here, the buoyant force can be further defined as the density of the seawater times the volume that is submerged of the apparatus times the acceleration due to gravity on Earth equals the mass of this apparatus times the acceleration of gravity due to the Earth. Here, gravity can be canceled out, and we're trying to find m. So m would simply be equal to 1,030 times 0.25 V, given that 25% of this volume is submerged. This would give us 257.5 V kilograms. Now, we need to apply this relationship to the other planet. So if we were to do this, the buoyant force is again must be equal to the mass times the gravity. So the buoyant force, the force due to the liquid that is displaced, must equal the force of this gravity. Now, here we're going to further define this as the density of glycerine, because now it is in a glycerine ocean instead of a ocean of simply salt water. And this is going to be times V2 times the acceleration to gravity on this new planet Caasi equals mass times the acceleration due to gravity on, again, Caasi. So this, again, can be canceled out, and we're finding V2. So V2 can simply be the mass divided by the density of glycerine. At this point, we can see that we simply need to substitute for our values. 257.5 V kilograms divided by the density of glycerine being 1,260 kilograms per meter cubed. We find that this is going to be equal to 0.204 V, which means that on Caasi, 20.4% volume submerged. So given that we have 25% of the volume submerged, given that is floating on seawater, transferring this over to a new planet with a new gravity, a new acceleration due to gravity, but more importantly, a new type of liquid. Rather, instead of seawater, we're using glycerine. We can find that on Caasi, 20.4% of the volume will be submerged of this apparatus. So here, it is also important to note that when finding relative percentages of this volume, the gravity change actually did not matter in the end, and it simply canceled out. So again, that final answer is 20.4% of the volume is submerged. And that's the end of the solution. Thank you for watching.